This is where the chapter gets very difficult because now we are factoring polynomials and adding and subtracting rational expressions, which requires common denominators, which means we have to know how to look at two polynomials and find out how to multiply things and algebraically manipulate them to the point that they are the same, which really isn't that bad as long as you know how to factor polynomials. It's very tedious. That is the part that I would say is the most difficult part of the section, is just how tedious it is and how long you have to be focused on one problem.
So our homework isn't
Now, what is the least common multiple? We have to remember the difference between a factor and a multiple. They're kind of opposites, they go in the different direction. Take the number 6, for example. The factors of 6 are 1, 2, 3, and 6. Those are the factors. The multiples of 6 are 6, 12, 18, 24, 30, 36, so on and so on and so on. So the factors are the things that are smaller than the number that multiply up to it. The multiples are the things that are bigger than the number that it multiplies up to be. So, the least common multiple of 2 and 6 is 6. 6 is a multiple of 2, 6 is a multiple of 6, so the smallest multiple that they both have is 6. The least common multiple of 3 and 7 is 21. The least common multiple of 4 and 6 is 12.
I apologize.
So I chose these three sets of numbers specifically. The first one is an example where the least common multiple of two numbers is actually just one of the numbers. The second set, least common multiple, is actually just those two numbers multiplied together. And then the third set was specifically designed to follow these ones up. 24 is a common multiple of 6 and 4. It is just not the least common multiple. There is a multiple that is in common that is smaller than 24, 12 to be specific. So, what if we ask about the least common multiple of two polynomials? The way we do this: take x squared plus 4x minus 12 and factor it. X plus 6 times x minus 2. Take x squared minus 6x plus 8 and factor it. X minus 4 times x minus 2. So when you're looking for the least common multiple of polynomials, the first step, factor them. Then we're actually going to see what the least common multiple is. Look at the factored forms one at a time. Here in white, we have an x plus 6, we have an x minus 2. So we know that our least common multiple will have an x plus 6, and it will have an x minus 2. It'll have everything that's there. Look at the factored form here in gold. An x minus 4 and an x minus 2. Our least common multiple will have all of this. The thing is, we already have an x minus 2 written down. There's no reason to write it again. Once you have done that, you have the least common multiple. Every factor from here and every factor from here, making sure to just not duplicate things. What is the sum here? We're adding two rational expressions. First thing you want to do, factor the denominators, because the denominators are what we're going to look at and find the least common multiple. So it's 4 over x times x plus 3 plus x minus 2 over x plus 3 times x plus 3. Because we have x squared plus 6x plus 9, what two numbers multiply to be 9 and add to be 6? 3 and 3. Now the thing there is, I want to choose to rewrite that as, instead of x plus 3 times x plus 3, I'm going to choose to write it as x plus 3 squared. Same thing. If you multiply something by itself, you can say that it's that thing squared. Then I want to find the least common multiple of my denominators. And I'm going to use that to be my common denominator. So here, look right here, what factors do I have? X and x plus 3. So I know my least common multiple will have x, and it will have x plus 3. Then look here, what do I have? X plus 3 squared. So in this case, I know that my least common multiple should have x plus 3 squared. In the last problem, we had x minus 2 in both, so we didn't want to copy it down again. But here we have x plus 3 and x plus 3 squared. When you have the same factor in both denominators, just pick whichever one has the highest exponent. So we have x plus 3 to the first and x plus 3 squared. Our least common multiple then is going to be x plus 3 raised to the highest power, in this case squared. This is our least common multiple. Which means that's what we want our common denominator to be. My common denominator is going to be this. What do I multiply here to get x times x plus 3 squared? I need to multiply it by x plus 3 over x plus 3. What do I multiply here to get x times x plus 3 squared? I need to multiply it by x. And just remember, whatever I multiply in the denominator, I must also multiply in the numerator. And the reason for that is this fraction right here has a numerical value of 1. So if I multiply this whole thing by 1, I haven't changed it. And I'm not allowed to change it, so that's good. So we have 4x plus 12 over x times x plus 3 squared plus x squared minus 2x over x times x plus 3 squared. So to add two fractions, I need a common denominator. Everything I've done up to this point is just trying to get a common denominator. So, to add two polynomials, you just combine like terms. We get x squared plus 2x plus 12 all over x times x plus 3 squared. They ask for this answer in simplest form. So at this point, you want to look at the numerator. Does that factor nicely? So this numerator doesn't factor nicely, so this is the simplest form. And any restrictions on the variable, the restrictions, to look for them, you need to come right here. To this step when you factor the denominators, what values for x make this denominator 0 or this one 0? 0 and negative 3. Same exact thought process as the previous problem. Main difference, that problem was addition, this one's subtraction. Everything else is the same. It's just at the end, you're going to be subtracting two rational expressions as opposed to adding them. So we want to start by factoring the denominators. We do x plus 1 over, this one is x plus 4 times x minus 2, minus x over 4 times x minus 2. So we factored our denominators. We then want to identify our least common multiple. Our least common multiple in this case, we know it should have an x plus 4. We know it should have an x minus 2. We know it should have a 4, and we know it should have an x minus 2. We only have to write the x minus 2 down once because the exponent here is a 1, exponent here is a 1. So my least common multiple is 4 times x plus 4 times x minus 2. So I have to multiply here by 4 over 4, and here by x plus 4 over x plus 4. Because again, once you've identified the least common multiple, you just want to know, what do I need to multiply this denominator by to get the least common multiple? 4. What do I need to multiply this by to get the least common multiple? X plus 4. So we have 4x plus 4 over 4 times x plus 4 times x minus 2 minus x squared plus 4x over 4 times x plus 4 times x minus 2. So we factor the denominators, identify the least common multiple, manipulate our fractions so that they each have the least common multiple as their denominator. That's where we are at this point. Then you combine the two. And the only thing we have to remember here is that this subtraction gets distributed. When we do that, we get negative x squared plus 4 all over 4 times x plus 4 times x minus 2. Now this is where we have to have some foresight, and we have to be comfortable with factoring polynomials. And the special case of factoring polynomials that is absolutely the most common and the one you need to be on the lookout for, in the numerator here, if I factor out a negative, I get this. Why is that important? Because x squared minus 4 is a difference of 2 squares. You have to be on the lookout for difference of 2 squares. It is the most common, most useful, special case of factoring polynomials. Other than that, you'll probably see a lot of the generic quadratic factoring, stuff like that. Difference of 2 squares is the special case you must be on the lookout for. It's very important in this problem because they do ask us for the simplest form, and when we do the difference of 2 squares there, the x minus 2's cancel. So we end up with negative x plus 2 over 4 times x plus 4. This is the simplest form of the difference they asked us for. And then you have to remember to state the restrictions on the variable. You want to come right back up here to the step where you just factored the denominators. What values of x make either of these two denominators 0, negative 4, positive 2? So x cannot be negative 4 nor positive 2. What is a simpler form of this expression? What we have to realize is that they're asking for a simpler form. The form we get to may not look entirely simple, but we have an expression with a fraction divided by another expression with a fraction. Our goal is to get rid of as many fractions as possible. There are too many fractions there. This is a type of situation where this should just be broken up into 3 parts. First part, what is 3x minus 1 over y? This should look much easier. We need a common denominator. Multiply right here by y over y. So we get 3xy over y minus 1 over y. So why did I multiply by y over y? To get my common denominator. At this point, just combine the two, 3xy minus 1 all over y. Second part of the problem. We just simplified the numerator. Now let's look at the denominator. Y squared over x plus x. multiply, not there at all, actually. Multiply here by x over x. We get y squared over x plus x squared over x. Again, the reason we did that, to get a common denominator. Combine those together, we get y squared plus x squared all over x. And now that I have simplified each of them individually, the third part of the problem, what is that simpler numerator divided by that simpler denominator? How did that make things easier? Because now I'm just dividing one fraction by another fraction, which means that we are multiplying one fraction by the other's reciprocal. Like this. And this, depending on how you want to look at it, becomes very easy or very difficult. I would say it becomes very easy because you're multiplying those two fractions, nothing factors, nothing cancels out, so all that you have left to do is multiply straight across. We get 3x squared y minus x all over y cubed plus x squared y. So I argue that that makes it a bit easier because nothing factors and nothing cancels out. Some of you that just would not be able to accept the fact that nothing factors and nothing cancels out, that may become a little bit more difficult. But just take it for what it is. Nothing cancels, multiply it all together. What I have boxed in there is a simpler form than what the original problem was. Again, primarily because there are fewer fractions. Now, one fraction. The original problem had 3 fractions. So this is a bit simpler form. All right, in this problem with internet connection, what we're going to do is we're going to say that x is the number of kilobytes for the picture. So to find the combined rate, what we need to do is get the total number of kilobytes divided by total time. That's going to give us the total kilobytes per second, which should make sense. The difficult part is how do we write expressions that give us the total number of kilobytes and the total time. Total kilobytes is the easy one. If x is the number of kilobytes for the picture, we'll be more specific, for the picture, then the total number of kilobytes we're talking about is x plus x. That's the number of kilobytes you're downloading, and then you upload that same exact number of kilobytes. So that is our numerator, that's the total kilobytes. Now what about total time? We need to figure out what's an expression for how long it takes to download the picture, and then how long it takes to upload the picture. And similarly to how miles per hour would work, what you say is if you know how many kilobytes there are and you know how fast it was going, then the total time it took to download is x over 1400. And the total time it took to upload the picture is x over 350. So now we have a complex fraction just like our previous example. We want to simplify the numerator and the denominator, which in this case is not overly complicated in the numerator anyway. The numerator is going to be 2x. The denominator, the common denominator we need there, this one's a little bit easier back into the comfort zone because the denominators are just numbers. What is the least common multiple of 1400 and 350? It's 1400. So we have x over 1400 plus, and the way we get that here is we multiply this by 4 over 4. So we get 4x over 1400. That becomes 2x over 5x over 1400, which is You're dividing by a fraction, so it's 2x times the reciprocal, 1400 over 5x. The x's cancel out. So we're left with 2 times 1400 over 5, which is 560 kilobytes per second. That is the combined rate for the entire process.